In this example, we have a golfer hitting a ball. The mass of the ball is 0.0459 kilograms, and the golfer must hit the ball with an initial velocity of 30.0 meters per second at an angle of 45 degrees. The ball and the club are in contact for 0.120 seconds, and the question is, what force must the golfer use to achieve that initial velocity? In order to figure out force, we're going to have to figure out the change in momentum. Well, when the golf ball is sitting on the tee, its momentum is 0. However, once it leaves the tee, it's going to have momentum. We need to calculate that momentum. Well, momentum is mass times velocity. So momentum is 0.0459 kilograms times 30.0 meters per second. When you work that out, you get 1.38 kilogram meters per second. The force can now be calculated with delta P over delta T. Now remember, the golf ball sitting on the tee initially with 0 momentum. Its final momentum is what we just calculated. So the change in momentum is simply final momentum minus initial momentum, or 1.38 kilogram meters per second. The delta T is the time in which the ball and the club are in contact. That's 0.120 seconds. When you work the numbers out in this equation, you get 11.5. But look at the units. When kilogram meter per second is divided by second, you get kilogram meter per second squared. So the answer is 11.5 kilogram meter per second squared. But a kilogram meter per second squared is a newton. So the answer is also 11.5 newtons. Now remember, force is a vector, and so is momentum, and so is velocity. Well, if the velocity has an angle of 45 degrees, then the momentum will have to have an angle of 45 degrees, so the force will have to have an angle of 45 degrees. So the final answer is 11.5 newtons at 45 degrees.